Hello, good morning. Any questions if you have from previous class? The last class we were talking about light. We are trying to understand what is light. And I started my discussion with Newton's theory, how he thought light is made of particles, which was rectified by Huygens. Light is a wave, travels in ether. Turns out there is no ether. So Clerk Maxwell, one of the greatest scientists, he hypothesized that light is an electromagnetic wave. It is vibration of electric field and magnetic field. And one of the things about electric field and magnetic field, that when electric field changes, it produces magnetic field. And when magnetic field changes, it produces electric field. So light is like a self-sustaining electromagnetic wave, because as electric field oscillates, that oscillation will produce magnetic field, but as magnetic field oscillates, it will produce electric field. So it can exist irrespective of charge also. I started this entire discussion about electric field and magnetic field. They exist because of charge or magnets, but they can exist irrespective of that. They can have their own independent existence. So when we think of sunlight, and sunlight carrying all of that energy or momentum, whatever it does carry, then it essentially is energy of electric field or magnetic field, which travels through millions of kilometers and can reach to Earth. So it almost seemed like that we have finally figured out what is light, although very soon it had to be rectified. I will continue that part later. In today's class, so why I went into this detail of about light, because this understanding allowed us to develop modern technologies. Once we knew that light is an electromagnetic wave, then we looked at its properties, because all waves have certain properties. When we think of particles, one of the most underlying fundamental property of particles will be mass, right? How much mass they carry. But when we think of wave, that does not make sense, defining wave for mass for a wave. But there are some other fundamental properties we should know about. So when we think of wave, the first thing which I discussed in the last class, we should know about is that what is this maximum oscillation, maximum vibration? This is called amplitude. So if wave has more energy, or if more and more energy is being transferred, the amplitude will be higher and higher. It should be very clear that amplitude directly also tells you that what is the energy which is being carried by the wave. That is the first thing. Second thing, second parameter which all of you already have studied again in your school days, that this distance between two maxima or two minima, this distance here, or this distance here, we call this distance. We often represent amplitude with A, we represent wavelength with lambda, a Greek letter, lambda. So ये दोनों जो है इनका जो unit होगा distance होगा. So we can have amplitude or lambda measured into nanometer or micrometer or centimeter, millimeter, kilometer, depending upon what are we talking about. तो ये तो बहुत straightforward है, but the next thing is frequency. Now what is frequency? Number of vibrations per second. What does that mean? So आप इसको ऐसे imagine करो that let's say in t second, some t unit of time, that t can be anything, it can be 1 nanosecond or 1 hour for that matter, that's not important. That let's assume that in t second, this wave vibrated once, that it was here at maxima, this point was at maxima, it went to minima, and again went back to maxima. That is one vibration. So it started, let's say, when I started my calculation, a particular point was at maxima, it went to minima, and then it again went back to its maxima. So this is one vibration. And we often use a term called time period for this wave, that in t second, it made one vibration. So it's quite simple. That in t second, my wave vibrated once. And what is my frequency? In 1 second, how many vibrations are happening? Frequency को हमने कैसे define किया है? That how many times wave is vibrating in 1 second. So I am saying that in t second, my wave vibrated once. So in 1 second, it is going to vibrate 1 by t times. So this is frequency. Frequency is nothing but 1 by time period of the vibration of the wave. And frequency का जो फिर unit है, it simply is measured into per second, or a better unit is hertz. So when we say that sound has, for example, we have studied about that our ears can make sense of sound from 20 to 20,000 hertz, then essentially we are talking about that if air pressure is vibrating, let's say if it is 2000 hertz, then if this air pressure is vibrating 2000 number of times per second, then this sound is audible. So when I'm using the word 20 hertz sound, it essentially means that the air particle vibration is happening 20 times in 1 second. And when I'm saying 20,000 hertz, then it is again 20,000 number of times air is vibrating in 1 second. 20 to 20,000 is useful because that is where our ears can listen to sound wave. Less than 20, more than 20,000, we cannot listen to. So frequency is number of vibration per second, and we measure frequency into a unit called hertz, but hertz is nothing but per second. So when I'm saying 20 hertz, it is nothing but 20 per second, or 20,000 per second. But one more thing happens here is that in the same time, that wave vibrated once. So remember, wave also propagates. So this in the same time wave vibrated once in time t, the same point which was at maxima here, the wave distances by this much distance lambda. So in one vibration which happened in t second, the wave also traveled a distance of lambda. So now we can measure the velocity of the wave. If wave is propagating, remember one of the thing was that it is a disturbance which is propagating. So if something is propagating, it should have some speed. So let's try to calculate that speed of the wave. So it traveled a distance lambda into time t. So let's call this speed as v. But I just told you that 1 by t is nothing but frequency. So I can write frequency as f or nu. Let's use f here. So I find this very nice relationship that speed of wave, it's closely related to the frequency and wavelength of the wave. In fact, frequency and wavelength, they are not independent properties of each other. If we multiply both of frequency and amplitude, then we find speed of wave. And we also get to know that frequency and lambda, they are reciprocal to each other. Right? That if higher frequency means less wavelength, and vice versa. So light is an electromagnetic wave, and light travels with speed of light, 3 lakh kilometer per second, 3 into 10 to the power 8 meter per second. We often use this letter c to represent that. So I can now replace that v with c with for light, for example, I can simply write here I can represent that v with c, and c becomes f lambda, where c is 3 into 10 to the power 8 meter per second. Makes sense also, frequency ka unit is per second, lambda ka unit is meter, so c has unit of meter per second. This is a relationship we find. So when somebody did ask a question that was, what does this term gamma ray or X-ray mean? It essentially means, it's a very simple thing. It essentially means we are talking about gamma rays will have very high frequency, visible light will have less frequency, and radio wave will have even less frequency. So let me show that, show all of that. आई एक हैंडआउट अपलोड हुआ है आपका, सिग्निफिकेंट मिशंस ऑफ नासा करके मैंने ऐसे कुछ हैंडआउट अपलोड करा है. वन ऑफ द रीजन आई वाज नॉट टॉकिंग अबाउट जेम्स वेब स्पेस टेलीस्कोप, आई हैड अ क्वेश्चन इन द क्विज about James Webb Space Telescope. One of the option was that it operates at very low temperature. So one of the reason I was postponing this, because I wanted this handout to be uploaded, and then we will discuss it. So at the end of today's class, let me complete topic. In 5 minutes, I will briefly discuss that handout so that we can understand that particular statement, that how does how does it operate at very close to zero, absolute zero, and why that operation is actually important. Write down few things about light meanwhile. Yes. हाँ, I will discuss about polarization also. हमने एक्सपोसैट डिस्कस किया था. एक्सपोसैट का जो फुल फॉर्म था दैट वाज एक्सरे पोलैरिमीटर सैटेलाइट. तो वहाँ पे पोलराइजेशन क्या है, आई एम गोइंग टू एक्सप्लेन दैट. नाउ वी आर एट अ पोजिशन वेयर वी कैन अंडरस्टैंड अबाउट पोलराइजेशन ऑफ लाइट. राइट डाउन फ्यू थिंग्स हियर. Light is an electromagnetic wave. Light is an electromagnetic wave, that is vibration of electric and magnetic field. Vibration of electric and magnetic field. Vibration of electric and magnetic field. And the wave propagates. The wave propagates perpendicular to both electric and magnetic field. Wave propagates perpendicular to both electric and magnetic field. So electric field is perpendicular to magnetic field, and both electric and magnetic field are perpendicular to the wave propagation. If so, right hand thumb rule. So if my index finger represents electric field, middle finger magnetic field, my thumb represents propagation of wave here. And since it is a wave, all wave will have certain properties such as frequency, wavelength, amplitude, etc. etc. तो जो light का जो underlying feature है और जो underlying definition है, when we use the word gamma ray or X-ray, then essentially we are using frequency or wavelength. आप लिख सकते हो, the term electromagnetic spectrum, the term electromagnetic spectrum, the term electromagnetic spectrum essentially signifies electromagnetic waves of various frequency. Electromagnetic waves of various frequency. So, okay, this is what I meant when I said that the time wave vibrate once, that red dot, it also travels a distance of this wavelength. And when it reaches again, you have again, it reaches to this, it travels a distance of one wavelength. And that is how you have this relationship, speed of wave is equal to wavelength divided by time. And you find this relationship, V is equal to F lambda. So wavelength and frequency, they are reciprocal to each other. And when I use the word electromagnetic field, then electromagnetic field is vibrate. So electric field here is represented with that blue arrow. Red arrow is magnetic field. They both themselves are perpendicular to each other. But the wave propagation is perpendicular to both electric and magnetic field. I can now define polarization. Polarization is that electric and magnetic field का direction अगर fixed नहीं हो, direction तो है, but बहुत random direction है. That electric and magnetic field, they do not have any fixed direction. They are not vibrating in one plane. They have a very random vibration. All the time, जो electric field का जो direction है, it is changing. Whenever we have a light like this, we call this light unpolarized light. So when we use the word unpolarized light, it essentially means that I'm talking about a light whose electric field direction is not fixed. It is random in any direction. Such type of light is called unpolarized light. But if that electric field direction is fixed, that let's say if it is only vibrating in a particular plane, up and down, only vibrating up and down in one plane, not in any random plane. When it happens like this, we call this polarized light. So when we use the word polarization, it essentially means what is the measurement or what is the direction in which electric field is vibrating. And if that vibration is random, electric field vibration is random, then that is called unpolarized light. However, if it is fixed, then it is called polarized light. So natural light sources, for example, जो sunlight हम receive करते हैं, that is a very good example of unpolarized light. But there are a lot of things which makes unpolarized light as polarized light. जैसे reflection does that. When light gets reflected from a surface, some of the light, not all of it, some of light can become polarized. When light gets refracted, again it can become polarized. Even scattering can make polarized. But the best way to convert unpolarized light into polarized light will be help of certain type of filter materials which we call polarizer. जैसे you go and buy sunglasses, summer season में we often wear sunglasses, and you ask the salesman जो sunglass बेच रहा है that I want a polarizer sunglass और polar white sunglass, and वो अपने दुकान में ही एक उसने रखा होगा जो कि उसका impact भी दिखा देगा कि इसका effect क्या है. So the benefit of converting unpolarized light into polarized light is that it is able to remove all of that unnecessary glare. बहुत बार दोपहर में आप जाओगे, बहुत bright light है, बहुत glare है, and if you are wearing polarized glasses, then it will be able to remove that glare part and it will be soothing to your eyes. So geometrically what it looks like, in this picture, the light which you see at the back, that yellow represents direction of electric field. But if this direction is random, if it is vibrating in any direction, there is no fixed direction per se. You cannot determine each and every moment that in which direction this electric field is vibrating. If you have a light like that, we call light, such type of light, as unpolarized light. But if, so for example, in this case we are using a polarizing filter, the same type of filter we often use in sunglasses also, that with the help of polarizing filter, now this light which has crossed through, this is an example of polarized light whose vibration is fixed. It is now only vibrating in specific direction, in specific plane. So such type of light is called polarized light. And polarization is not specific to only visible light. When we use the word polarization, we can measure polarization for all type of electromagnetic spectrum, including X-ray. So one of the way how EXPOSAT mission of ISRO aims to distinguish between various X-ray sources, that how a supernova will be different from a quasar or an accretion disk of black hole. I will explain meaning of all of these words in later classes, that how all of these are different. It can do that with the help of measuring polarization of X-ray. Right, so that was the purpose. It aims to measure polarization, but even that polarization carries information. I told you in the previous classes that how light carries information. So similarly, even polarization, that what type of polarization we are talking about, it carries information and it can help us in distinguishing various type of light sources. And this is what EXPOSAT aims to do. So coming back to the topic at hand, when I use the word electromagnetic spectrum, This is what electromagnetic spectrum looks like. But I can now divide this electromagnetic spectrum. आप लिख सकते हो, electromagnetic spectrum can be divided into gamma rays, X-rays, ultraviolet light, visible light, infrared light, microwave, and radio wave. And when we use these words, it simply means frequency is decreasing. And since frequency is decreasing, it essentially means that wavelength is increasing. So gamma rays will have the highest frequency, and radio waves, they will have the lowest frequency, and consequently gamma rays will have the smallest wavelength and radio waves will have the largest wavelength. One more thing about electromagnetic wave we should know here, that the amount of energy a particular light carries, a particular light photon carries, it also depends upon its frequency. So energy is, in case of electromagnetic wave, energy becomes, this is a sign of proportionality, so energy becomes proportional to frequency, and there is a very popular constant which is used to make it equal. This H is called Planck's constant. It's a very small value in the range of 10 to the power minus 34. That's not important. It is one of the most popular constant named after Max Planck, the scientist who figured it out or who calculated the value of this particular constant. The important point here is that energy and frequency, they are proportional to each other. Higher frequency means more energy, less frequency means less energy. So in this case, when I said frequency is decreasing, it also means that energy is decreasing. Which essentially means that gamma rays will have the highest energy and radio waves, they will have the lowest energy. Gamma rays have so much of high energy that they can only be produced because of nuclear changes. We discussed that in the previous module, जब हमने nuclear technology discuss किया था, that whenever a nucleus is unstable, there is so much of energy stored inside nucleus that an unstable nucleus will release light of very high frequency, we call gamma. I also told you that this gamma can be quite dangerous. This gamma can lead to genetic deformities, cancer. In very low dose, it has some applications also. We discussed all of that in previous classes. X-ray, uska frequency gamma ray se kam hai, but X-ray bhi काफी dangerous radiation hai, and longer exposure to X-ray is also not very good. UV light is also not very good, particularly UV light को भी further हम divide करते हैं UV A, B, C में. So UV light in general is not very good. Thankfully we have ozone layer around sun, and sun, by the way, emits lot of UV light. But we do have an ozone layer in the outer atmosphere which does not allow most of the UV light to enter inside Earth. And in this entire spectrum, spectrum simply means I'm talking about combination of various colors. Many frequencies put together, that is called spectrum. जैसे you have heard about the spectrum for the first time, not for the modern history book, but for that prism. जब आपने prism class 9th में पढ़ा था, that when I crossed white light and it became this 7 colors of light emerged. So all of those 7 colors together, we use the word spectrum for it. So that spectrum, however, was only and only spectrum of visible light. electromagnetic spectrum is much, much more larger. It includes gamma, includes X-ray, radio wave, all of that. Now I do not expect you to remember frequency or wavelength of most of this electromagnetic wave except this one. So visible light का जो wavelength है वो clear होना चाहिए. Visible light का wavelength will be 380 to 700 nanometer. जब side में लिख लेना, that wavelength of visible light is from 380 to 700 nanometer. And in the entire electromagnetic spectrum, the contribution of visible light is actually quite small, and let me show that. We have a frequency which can be 10 to the power 25, or it can also be 10 to the power 5. So a difference of 10 to the power 20, from 10 to the power 5 to 10 to the power 20. And similarly, we have wavelength, which is right now measured in centimeters. And it can vary from 10 to the power minus 15 to 10 to the power 5, or even more than that. And then you find that gamma ray occupies a very large range here. Gamma ray's frequency can be from 10 to the power 20, 10 to the power 24 also. X-ray also occupies quite a large part. Ultraviolet light little less than X-ray, but look at the visible light. Visible light is a very, very thin part of this entire electromagnetic spectrum, which we further divide because our brain can make sense of the 7 color, where wavelength lies from 380 to 700 nanometer. For the topic I am going to discuss, which is communication technology, we are interested in radio wave, the last one, जो सबसे last में यहाँ पे. तो जो radio wave का frequency है वो पता होना चाहिए. So radio wave का जो frequency होगा, radio wave's frequency will be, it can vary from 300 kilohertz, but even it can be 300 gigahertz. Let me come to all of this question. There is a question that which waves do our mobile phones or Wi-Fi emit? Let me answer all of this question one by one. So they emit radio wave. It should be very clear that since I'm talking about communication technology, we use radio waves. But how do we use radio wave? That is also something we should appreciate. That just if I only make a statement that we are using radio waves for communication, but how are we using radio waves for communication? And all of this again essentially includes mathematics. But we do not have to go into that. We will try to use our intuition, which I was talking about in the last class, that we will try to understand intuitively that how radio waves are used for communication. So I can do a simple calculation. जैसे मान लो if I have a radio wave of frequency of 30 gigahertz, I can calculate its wavelength. Wavelength will be what? C by F. What is C? 3 into 10 to the power 8 meter per second. This is 30 gigahertz. Giga is 10 to the power 9 per second. I can remove per second, say per second I can remove that. So this is 3 into 10 to the power 8. This is 3 into 10 to the power 10. This becomes 1 by 100 meter, which essentially is 1 centimeter or 10 millimeter. So if I have a frequency of 30 gigahertz, I found a wavelength of 10 millimeter. Now why this is important? Because think about the wavelength of visible light. Wavelength of visible light was in nanometer, 300, 400 nanometer. And wavelength of radio wave, that is into millimeter. So wavelength is much, much more larger compared to radio wave with respect to visible light. And by the way, wavelength of gamma rays will be even less. In fact, they will be the lowest wavelength, then X-ray, then UV light. We discussed that. So now I can answer this question. Let's start with the first and the simplest question, that why radio waves for communication? Why not visible light? Why not something else? So one of the most important point here is that we are actually trying to use visible light for communication. And I will talk about some of the technologies, how are we trying to do that. बट मॉडर्न कम्युनिकेशन, चाहे वाईफाई राउटर हो, चाहे हमारा मोबाइल फ़ोन हो, they use radio wave. जैसे, to answer the question that which frequency Wi-Fi uses. Wi-Fi uses often 2.4 gigahertz or 5 gigahertz. The most recent Wi-Fi routers, which as of now are not available in the market, may also use 7 or 8 gigahertz. But most of the Wi-Fi routers which we are using in our homes, they are using frequency of 2.4 or 5 gigahertz. So 2.4 is radio wave, 5 gigahertz is radio wave. Another question you asked is that what about our mobile phones? So it depends upon in which generation you are talking about. If you're using 4G, then very good chance you're using 1-2 gigahertz or even less than that, maybe 800-900 megahertz. But if you're using 5G, then there is a very good chance that you are using some higher frequency like even 20 or 30 gigahertz, that is possible. So now think about what does this word gigahertz mean. If I'm saying 30 gigahertz, it essentially means that the electric field associated with this particular wave, it vibrates 3 into 10 to the power 10 times in 1 second. That is the meaning of this word. When I use the word 30 gigahertz, it essentially means that the associated electric field is oscillating. It is going up and down 3 into 10 to the power 10 times every second. 30 trillion times every second. That is the meaning of this word frequency. So when we use the word gamma ray or X-ray or UV or whatever, it is essentially frequency and wavelength we are talking about. We can only perceive, or our eyes and our brain can only perceive the visible light part. But other light, we cannot perceive it, but it can affect us. जैसे particularly जो higher frequencies हैं, gamma rays, X-rays, UV light, they are quite dangerous. They are type of electromagnetic wave, we call them ionizing radiation. So let me explain this also, that you'll come across this word from time to time in newspapers. Called ionizing radiation versus non-ionizing radiation. Ionizing radiation simply means we are talking about gamma rays, X-ray, UV light, that this electromagnetic wave has so much of energy because of high frequency, that as they travel through a medium, they give electrons enough energy, so their energy can be absorbed by electrons, and electrons will come out of the atomic bond. So because of that, the medium becomes ionized. Hence the word ionizing radiation. So for example, let's say that in this room, if I have sources of gamma ray propagating here, then the air inside this room will become ionized. Gamma rays has so much of energy that as they travel, if their energy is going to be absorbed by by electrons, then electrons will come out of the atom and the medium becomes ionized. If electrons are coming out of the atom, whatever is left is positively charged. So if you are exposed to ionizing radiation, such as gamma ray, X-ray, UV light, then there is a risk you are much more vulnerable to mutations, cancer, genetic deformities, all of those things. But other type of radiation, infrared, microwave, radio wave, they are not ionizing radiation. They cannot knock electron out of the atom. What type of problem they can cause, I will try to explain that. हम 5G अभी पढ़ेंगे हम. आपने पढ़ा होगा 5G को लेके बड़ा सारा fear है that 5G is causing cancer and what not. So we'll try to understand that how true that is, and is there any some authenticity to such type of claims that 5G is causing all sort of problems. So we will try to understand that. But let's now talk about that what are some of the fundamental principles which are used in communication technology, right? So give this heading, or before giving this heading, in fact, you can write down few things here. For communication technology, radio waves are used. Radio waves are used. Generated artificially by transmitters and received by receivers using antennas. received by radio receivers using antennas. Received by radio receivers using antennas. There is a question that do we need to remember all these formulas and calculations? ज़्यादा formula तो मैंने लिखा भी नहीं, एक ही formula लिखा है, frequency is equal to. So I have only written one formula, c is equal to f lambda. Velocity of wave or speed of wave is equal to frequency multiplied by its wavelength. And yes, I do think that formula we should know. This formula I remember reading that in class 9th. So I do think that you should know about this formula. And apart from that, calculations we never mug up. Should be very clear that calculations we do not remember. Calculations we do. So if I give you frequency 30 gigahertz, you calculate lambda, right? Because we know how they are related. And why they are related, I explained that also. So why that c is equal to f lambda, I explained that earlier. And it's a very simple calculation. Velocity is equal to distance by time. One of the most fundamental thing, how we define velocity, using that concept I derived that relationship. तो ऐसा कुछ भी हमने बहुत complex calculation नहीं किया है. But to answer your question, yes, we should remember fc is equal to f lambda. And we should remember that only visible light is visible to us. That is why we are calling them visible light. There are organisms which can perceive UV light also and infrared light also. There are a lot of insects which can see in UV light. There are certain organisms which can see even in infrared light. And how they think of world or what type of color they see, we will never know that because our eyes can only perceive that visible, and particularly we are much more sensitive towards the red color or blue color. Just we are not that sensitive to violet color, but we are sensitive to blue color or red color, but we are not that sensitive to violet color. But there are insects which are much more sensitive to violet or even ultraviolet color. And sunlight carries ultraviolet. So think about how those insects perceive world, right? So perception of the world depends upon, again, our sensory organisms. That has deep philosophical implications. That how do we perceive world? It depends upon our sensory organisms. There is a question that gamma rays are also used in cancer treatment. Yes, they are. In very low doses, if we can have controlled doses of gamma rays, then they can destroy tumorous growth. They can destroy tumorous cell. But I also told you that as there will be side effects because they will also destroy a lot of healthy cells. And jo radiation treatment hai, that has a lot of side effects because of that. How do they cause cancer? So what is cancer? That is something we should know. Cancer essentially is some sort of erratic growth of your cell, that some cells are not following typical rules and regulations, that a certain mutation has occurred. Now we have to know the word mutation. What is mutation? Mutation is a spontaneous change in your genetic structure. That jo aapka DNA hai, it has went through some sort of alteration, some sort of change. Now why that change can happen? That change can happen naturally also as part of division, but if you are exposed more to more radiation, then that change can happen. And when that change happens, it will induce a mutation, and that mutation can be good or bad or neutral. Bad mutations often lead to what we call cancerous growth. Or not often, but sometimes bad mutations can lead to cancerous growth. So why do they cause cancer? Because of high frequency, they can make changes to our genetic structure, and that change in genetic structure may not be good. It can lead to a cancerous type of growth. Write down few more things here. To prevent interference among different users, the generation and transmission of radio waves, is strictly regulated by national laws. It's strictly regulated by national laws. and coordinated by a global body, International Telecommunication Union, International Telecommunication Union, International Telecommunication Union, an agency of United Nations, an agency of United Nations. Let me explain this line. Just because we can use radio waves for communication. So coming back to my question, why radio waves for communication? Two very obvious reasons. पहला, इनको generate करना सबसे आसान है. Remember, gamma rays can only be generated because of nuclear changes are very dangerous. In any case, we are not going to use them. Same goes with X-ray, same goes with ultraviolet light. Visible light को generate करना मुश्किल है because they have much more energy. But we are actually trying to use visible light or infrared light for communication. So the first reason why radio waves for communication, because radio waves को generate करना because they have very less energy. So I can have a device with minor changes in electricity and magnetism, we can produce radio waves. तो इसको generate करना सबसे आसान है, पहला reason. दूसरा reason, radio waves के लिए बहुत सारे जो solid objects हैं, lot of solid objects, they are transparent for them. I told you that in the previous class that this entire concept of transparency and opaqueness, it now depends upon which frequency of light we are talking about. So for visible light like red or orange or yellow or blue, this wall is opaque, that glass is transparent. But for radio wave, that glass is also transparent and that wall is also transparent. So I can receive a phone call here, even though all of the rooms and all of the doors and windows are closed, but I will be able to receive a phone call here. So clearly radio waves can cross through these walls and these glasses. So another reason why radio waves can travel through even solid objects as if they are not even there. That does not mean they are not affected. They are affected. They are affected by metals a lot. They are affected by atmospheric condition a lot. बारिश बहुत हो जाए, radio waves will be scattered, they will be absorbed. Snowfall हो जाए, radio waves will not be able to travel very far. So they are affected by medium, but compared to other type of light, such as visible light or infrared light, they are affected much less. So radio waves can propagate through larger distances, can cross through even solid objects as if they are not there. And whatever problems they do go through, we can make a system to overcome those problems. And that is what my next topic is. Give this heading, basic concepts associated with communication technology. Basic concepts associated with communication technology. This entire electromagnetic spectrum, even within that radio spectrum, is further divided into these frequency bands. And this division is done by International Telecommunication Union. And for a specific purpose, you can use a specific frequency band. Often that does not have a lot of scientific basis. It is simply because we do not want to lead to a situation where many people or many organizations are using similar type of frequency, and that can lead to a lot of interference which we want to avoid here. So how to ensure that people are using frequency bands in a way that we can cater to most of the requirements without any type of interference, and that is why regulation is required. So at country level regulation will occur, but communication systems are not just national communication systems anymore. We have global communication system, so we require some global regulatory body also. So what type of frequency band will be allotted for what type of purpose? Now this is also very important. Frequency bands are allotted. So I can have a device, let's say I have a device which can generate a radio wave. Does that mean that I can develop a communication system all by myself? The answer is no. In fact, for a lot of frequency bands, if I try to generate without permission, there will be a case against me and I will be thrown to jail. So frequency bands are properly regulated at the country level, and then they are further regulated, or further this entire division that occurs at the global level by International Telecommunication Union. So ITU cannot dictate your laws, but ITU will tell you that what type of laws you need to develop, which type of frequency bands which you need to allow for what type of purposes. So they cannot replace your national laws, but they will give you a direction. And this direction is important, that all across the world we are following same set of directions, same set of rules and protocols. I told you in the last class that that is one of the most essential part of communication technology. So all communication systems, and by the way, we do the same thing in case of satellites. In the previous class, previous classes I talked about communication satellites. Space technology में हमने communication satellite discuss किया था. And when you come across communication satellites in newspapers or even in your current affairs magazine, you'll come across this term that this communication satellite using something called Ka band or L band or C band. So what does those terms mean? It essentially means a frequency band. So for communication satellite, the frequency band which has been allocated, and again, who has done this allocation? International Telecommunication Union. So the frequency band which has been allocated is from 1 to 40 gigahertz. So जितने भी communication satellite हम launch करते हैं, they operate somewhere between 1 to 40 gigahertz. But that 1 to 40 gigahertz, which is radio wave, is further divided into many smaller frequency bands. जैसे you have this frequency band called L or S or C. So when I use the word L band, it essentially means that there is a satellite which is operating between 1 to 2 gigahertz, S band 2 to 4, C band 4 to 8. Nobody is expecting you to memorize that, and nobody is also expecting you to know that C band का use क्या होगा, L band का use क्या होगा, ये जो Ka band है 26 to 40 gigahertz, उसका use क्या होगा. So nobody is expecting you to know that. But it shouldn't confuse you. Next time when you come across this word, that this satellite is using Ka band, that should not be confusing. It essentially means that it is using 26 to 40 gigahertz, and that, by the way, this particular frequency band is quite useful for internet services. If you want to provide satellite-based internet, that Ka band will be very useful. If you want to use GPS satellite, that L and S band will be very useful. For military communication, that X band, 8 to 12 gigahertz, that is very useful. Useful in the sense that ITU has decided that this frequency will be used for this particular purpose. When we do radar imaging, we do often that in L band or S band. Remember I told you in the previous class, we do radar imaging. We use radio waves to know about a particular surface. So radio waves, which even remote sensing satellites are using, they will be using somewhere some frequency band here. And that is why I talked about one of the missions, NISAR mission. Discuss किया था हमने NASA synthetic aperture radar, ISRO synthetic aperture radar technology. I told you that this NISAR mission is using L band and S band. So it is not a communication satellite. It is a remote sensing satellite. A remote sensing satellite which is using radio waves to image Earth's surface. But which radio wave it is using? It is using L band, which essentially means that your device hai, it can record about Earth's surface in L band, which is 1 to 2 gigahertz, and S band, which is 2 to 4 gigahertz. So I will repeat this. जैसे निसार के लिए तो चलो फिर भी आप याद रख लोगे, L band, S band, इंडिया का मिशन है, नासा से हमने कोलैबोरेट किया है, बट इन जनरल ये मेमोराइज करने की कोई ज़रूरत नहीं है. Nobody is expecting you to do that, and nobody is also expecting that इसका specific objective क्या होगा. But when you come across these terms next time, it shouldn't confuse you that what does this term mean. It's simply we are talking about a particular frequency band of somewhere between 1 to 40 gigahertz. Okay. All communication systems, the simplest schematic diagram which I can represent of communication systems, all communication systems essentially will include that there is some information source from where I want to propagate this information. For that I have invested into an infrastructure. That infrastructure I am calling communication system. That whatever information I want to send, I first have to convert that into a form which can be transmitted using communication system. So I need a transmitter which can convert my signal, whatever my message is into a form which can be propagated. Just in our day-to-day life, when I'm using sound wave, then this is my communication system, the voice I'm creating. that is my information, and this information is using air. So in this case, air becomes my communication system, and so transmitter is my vocal cord, but the eardrums which you have, that is like a receiver. Those eardrums start vibrating, and that vibration can be made sense by your brain. That brain knows what I am trying to speak here. So you have a transmitter which transmits signal through some sort of channel. That channel can be air, that channel can be some wire, that channel even can be wireless communication. So air-based communication is wireless communication. I have a receiver which receives that signal, and wherever I wanted to send that signal, it has been, I have fulfilled each and every aspect of it. With this one problem, that there can be some unwanted signal in this entire system. So whenever we have some unwanted signal, we use a word noise here. Jaise, I am speaking here in this class, and few of you start talking in between. That is an example of noise. It's not required. Class में कोई ज़रूरत नहीं है उसकी. But that is a noise which is part of the system. That मेरा goal यहाँ पे क्या होगा? I will say that please do not talk in the class. So मेरा goal होगा that I do not want such type of noise. But this noise is part of the system. But there is also a scenario that I am delivering this lecture, and यहाँ पे कुछ लोग बुलेट चला रहे हैं. बुलेट चलाने वालों को दिखाना है कि वो बुलेट चला रहे हैं, तो बहुत ज़्यादा एक्सेलेरेटर अपना यूज़ करेंगे. So let's say or some construction work has started happening on the roof here. Right, it's a building. India में हर जगह construction चल रहा है. Some construction work is happening on the roof. Now that is causing a lot of noise. Not part of the system. It is not part of the system, but still it is causing noise, and it is going to cause problem here. Again, I will try to, what I will do, I will go and perhaps request that please do not do this right now, do it later. The point I'm trying to make here is that whatever communication systems we do use, first my data input has to be converted into some sort of signal, a signal which can be transferred from a transmitter to receiver. But I also have to ensure that if there are some unwanted, undesirable signal, which I am calling noise, then how to minimize or hopefully eliminate. Often elimination is very difficult, but how to minimize that noise so that my receiver can easily distinguish between signal and noise. जैसे if I am delivering this lecture, थोड़ा बहुत कोई construction चल रहा है, some noise is coming, but still all of you can make sense of it. But if that sound starts becoming very loud, and then all the time you are getting disturbed, you are not able to make sense of what I'm trying to speak here. So that will be a noise which now is not resolvable compared to the signal which I am delivering here. So all communication system का goal क्या होगा कि signal to noise जो ratio है उसको हम इस तरीके से करें that जो मेरा receiver है it is able to distinguish between what is signal and what is noise. So how do we do that? This is what I'm going to discuss. Let's start with the very first thing. I'm going to define some terms here. I'm going to explain all of these terms. The first is signal itself. Signal. Information converted into electrical form and suitable for transmission is called signal. Suitable for transmission is called signal. Devices called transducer, right on. Devices called transducer. Devices called transducer converts one form of energy into another For example, to all the online students, I know that you are very curious. Let the topic be completed, and lot of answers, lot of questions you are asking, it automatically will be answered. Right, on an electrical transducer, sorry, किसका? वही हम लिख रहे हैं. An electrical transducer converts a physical variable such as pressure, temperature, etc. into a electrical signal. Let me explain this. The transducer is a device which can convert one type of variable into an electrical signal. For example, I'm using mic here. Right? This is mic I'm using. Or lot of times whenever we are using mic or speakers, so it essentially what it is doing, it is trying to increase the intensity of sound. We call that amplification. I'm going to explain that. But the point here is that sound is nothing but pressure variation. And I am trying to convert that pressure variation into a corresponding electrical signal. Because this electrical signal can be propagated with the help of, let's say, some sort of wire. It can be a copper wire. It can also be propagated with the help of light signal. But propagation becomes easier if it is an electrical signal. So I have a sound which is pressure wave. I converted that into electrical signal. I propagated that electrical signal into a communication medium. At a receiver, that receiver is capable enough to convert it back from electrical signal to that pressure variation, and it can produce a sound. So transducer is a device which can convert one type of variable into some other type of variable. Electrical transducer, some physical variable such as variation in pressure, and it can convert that into an electrical signal. Now, I'm going to make you write a statement, but I will explain this later. Write it down. Signals can be analog or digital. Signals can be analog or digital. What does this mean? I will explain this. Second is noise. Noise. It refers to unwanted signals. Unwanted signals that tend to disturb the transmission, and processing of message signal. Sorry? Message signal, not massive. Message signal, transmission and processing of message signal. Give the next heading, attenuation and amplification. Attenuation and amplification. Attenuation and amplification. When I'm speaking, I'm using this mic here. Because if I do not use this mic, then the sound wave which I'm using, I'm not loud enough that I will have enough sound perhaps at the back of the class. So the reason here is that whatever energy I'm producing because of sound wave, that sound travels more and more distance, it occupies more and more area. So the amount of energy I am producing is the same, but that energy is now occupying more and more area. So we use often a word called intensity. Now, intensity, we do know that it has something to do with strength or something like that, but intensity has a very specific definition in physics. It essentially means that how much energy is carrying per unit area per unit time. That in 1 second, in 1 unit area, how much energy is carrying. Just say whatever sound wave I am emitting, I am producing here, it has some energy, but that energy now goes on to occupy more and more area as this sound wave propagates. So clearly that energy per unit area is decreasing, which essentially means that its intensity is decreasing. And that is why if I do not use this mic, then maybe people at the back will not be able to listen to my voice very clearly. So that loosening of strength, that loss of energy as a signal propagates is called attenuation. Simple. That as signal propagates, it loses some energy to the surrounding, or also because of the fact that same energy occupying more and more area. So amplification is a process which is exact opposite to attenuation, that I try to increase the amplitude, which essentially means to energy of the signal. So in this case, I'm using this power source, this mic here. This mic has a battery. With the help of this battery, I can amplify my voice. Amplify here simply means that if I had a signal which as it propagated, it attenuated. That is loss of strength of signal. But with help of this mic, now I have a sound wave like this, and now it can travel to more distances, and people even at the back can make sense of it. So amplification का बस benefit ये है that it aims to increase the range of my signal. That even to larger distances the signal can travel, and even if there is a receiver, in this case your ears, that you are able to make sense of what I'm trying to speak here. तो आप लिख सकते हो, attenuation is loss of strength of signal. Attenuation is loss of strength of a signal while propagating through a medium, while propagating through a medium, while propagating through a medium. Amplification is the process of increasing the amplitude. Amplification is the process of increasing the amplitude, and hence the strength of signal. Hence the strength of signal using a power source. Using a power source to compensate for attenuation. To compensate for attenuation. To compensate for attenuation. Repeater. Next is repeater. तो अभी तो इस क्लास में यूजिंग दिस माइक आई ओनली हैड टू स्पीक इन दिस पर्टिकुलर क्लास. इसका रेंज हार्डली ये क्लास 50 मीटर का भी नहीं है, यहाँ से यहाँ 20 या 25 मीटर है. बट लेट्स से आई वांट टू सेंड माय वॉइस टू समवेयर few kilometers away, then this amplification is not more than enough. I need at every some distance. So for example, with the help of this amplifier, I'm able to increase the range of my signal. But then the moment it starts fading away, I need some sort of device which can pick up that signal and again can amplify it and then propagate further. I told you in the last class that Akbar Birbal story. Or think of all of the mobile towers, or think of the satellites. Everything is an example of repeater. So there is a mobile tower which is receiving your signal. Whatever radio waves are being propagated by your mobile phone, it is being received by a mobile tower, and then it recovers the message signal but amplifies it, so that when it propagates to the next tower or wherever it is going to propagate, the signal strength should not lose. Same thing is done by satellites, that some sort of radio antenna, radio transmitter on Earth, it's sending signal to satellite. The satellite can receive that signal, will change the frequency, because remember every satellite works on a specific frequency. So we'll change the frequency, but we'll also amplify it. And then we'll send that signal back to Earth in a broadcast form or in a point-to-point form also. Now, this is also something we should be clear, that there can be two types of communication, broadcast communication and point-to-point communication. जैसे radio जो हम सुनते हैं, that is an example of broadcast. All of the devices tuned to a particular frequency will be able to receive the signal. Radio, television are broadcast. But mobile phone is an example of point-to-point communication, that it can only reach to a very specific person who I'm trying to call. That will be an example of point-to-point communication. So satellite, when it receives the signal, changes the frequency but amplifies it. So in a way, satellite is working as a repeater. So whenever we have to increase the range of signal transmission, we will have to use many repeaters on the way, so that they can keep amplifying and they can keep propagating that signal into desirable direction. So repeater is also a very essential part of modern communication system. आप लिख सकते हो? A repeater is a combination of receiver and transmitter. A repeater is a combination of receiver and transmitter. Receiver and transmitter. A repeater picks up the signal. Repeater picks up the signal. Picks up the signal from the transmitter. From the transmitter. Amplifies it. Amplifies it. And retransmits it. Retransmits it to the receiver. To the receiver. They are used to extend the range of signal. They are used to extend the range of signal. Range of signal. Last three concepts. Bandwidth. This is a term we hear a lot, the term bandwidth in our day-to-day life. We also use that in our day-to-day life. You are very busy, I assign you some more work, you will say that I do not have bandwidth. Think about it, how we use the word bandwidth even in our day-to-day life. So when we use the word bandwidth in case of communication system, it has a very specific meaning. We are talking about essentially the range of frequencies which a system is operating or which a signal is operating. Bandwidth को हम ऐसे समझ सकते हैं. Imagine करो that ये पूसा रोड है, यहाँ पे बगल में जो रोड है, बहुत सारा ट्रैफिक लगता है. Because there is lot of vehicle footfall, it has to manage, and it does not have enough width. So you can think of bandwidth as the width of the road. But that width of the road, जैसे maybe this width of the road is more than enough if everybody was using just bicycle or just bike. But the same road is also using car, the same road is using truck, and you have multiple cars and trucks and bicycles and bikes, all of them together being traveling on this particular road. So the same bandwidth, the same width of the road would have been more than enough if it was only bicycle and bike. But the moment we started introducing car, it was not enough. Then we started introducing truck, it was further not enough. So you can think of, or you can analogously, you can understand bandwidth in case of communication system, that if I have a communication system which can operate across a very large range of frequency, which essentially means that it can handle more and more amount of data every unit of time. That more and more data can be transmitted using a communication system which can manage or which has very high bandwidth. So if I have a communication system operating at very high frequency range, then it means that it can manage more and more amount of data, and all of that data can run very smoothly. So bandwidth depends upon lot of factors. Bandwidth depends upon what type of signal we are talking about. Just in case of this road, this entire smoothness of traffic was dependent upon which type of vehicle I'm talking about. So similarly, even in case of signal, think of the space occupied by text message versus image versus a video. All three of them are three different type of signal, but a text message does not occupy a lot of space. And because of that, even with very small bandwidth, it can be transmitted with not a lot of problem. But if I have an image or if I have a video, then there will be problem if I do not have lot of bandwidth. Right? So it depends upon what type of signal you are talking about. But it also depends upon what type of infrastructure you are talking about. जैसे यही पूसा रोड को हम और widen कर दें. Same traffic footfall है, but we have increased the width of the road, and now it can manage all of that traffic, trucks and bikes and motorcycles, everything very, very well. In fact, we can also designate a place that this is within this larger bandwidth. This is a lane where only bikes will travel through, only cars will travel through, only bicycles will travel through. And maybe things will become smoother. So in case of Delhi, it did not, by the way. So this was something, I'm not making it up. This was actually introduced in Delhi a few years ago. Turns out by one of my own professors from my college. And it spectacularly failed. And I have taken a course from her. I do not want to name her. But it actually did not work really, really well at all. So in any case, in communication system, we try to do that. We try to create separate channels for separate type of data streams, so that those data streams do not have any interference and they can run very smoothly in communication system. So that also decides what is your bandwidth. And it also depends upon, just say for example, I have increased the width of the road, but now let's say road में बहुत सारे गड्ढे हैं, width हमने increase कर दिया, but quality अच्छा नहीं है. So now even though width is very high, but because of lack of quality, traffic footfall will not work very smoothly. So similarly, different type of transmission medium, they provide you different amount of bandwidth. Just say, if you are using old copper cables, which we did use for communication for telephones, then unka bandwidth बहुत कम है. When we started using wireless, air as a medium of communication, bandwidth increased. Now we are using optical fiber cables, and optical fiber cables, they have the highest bandwidth. And why they have highest bandwidth, I'm going to explain that why they can manage such a huge amount of data. But optical fiber cables, they have the highest bandwidth. Modern communication infrastructure is nothing without optical fiber cables. So you can write it down about bandwidth. It refers to the frequency range. It refers to the frequency range over which an equipment operates, or the portion of spectrum occupied by the signal, or the portion of the spectrum occupied by the signal आप लिख सकते हो same point in bandwidth in a communication system. In a communication system, the message signal can be text, voice. The message signal can be text, voice, picture, etc. Each of these signals has different ranges of frequencies. Each of these signals have different ranges of frequency. Similar to message signals, write down next point. Similar to message signals. Similar to message signals. Different type of transmission media. Different type of transmission media. Offer different bandwidth. Offer different bandwidth. For example, coaxial copper cables. Coaxial copper cables offer less bandwidth than free space. Offer less bandwidth than free space. Optical fiber cables provide the highest bandwidth. Optical fiber cables provide the highest bandwidth. Provide the highest bandwidth. So bandwidth, higher bandwidth, whenever you come across this word, more bandwidth, essentially we are talking about a communication system which is capable of handling more amount of data, and still the speed and transmission or all of that will not be adversely affected. That is the benefit of higher bandwidth. At higher frequencies you get higher bandwidth, but it also depends upon what type of communication system we are using. You can use free air, free space. We can use optical fiber cable, and turns out optical fiber cables have the highest bandwidth. I will explain this. But before that, last two concepts, let's come back to this concept of analog and digital signal. Write down few things, I will explain this. An analog signal is a continuous signal that varies over time. Is a continuous signal that varies over time. For example, continuous variation of voltage or current. Continuous variation of voltage or current. Continuous variation of voltage or current. Let me explain this. Sound wave which we are using in our day-to-day life, that's a very good example of analog signal, that when I'm speaking, the pressure is dropping and increasing. But that increase and decrease is not discrete. It is continuous increase or decrease. If I could plot this, that how pressure is changing with respect to time or with respect to space also, wave travels in both space and time, then I will have this continuous variation. That at a particular location, air particles are coming together, pressure increases in a continuous manner, then they go away together, pressure decreases in a continuous manner. So whenever I have a signal, so that is sound, but in normal communication signals we use electrical signal, and for electrical signal we often represent this with either voltage or with current, that I have a signal whose voltage is continuously increasing or decreasing in a periodic manner. We call such signal as analog signal. जो सबसे पुराने हम मोबाइल फोन्स यूज़ करते थे, we haven't used that in our life, but in 70s जो मोबाइल फोन्स आपने फिल्मों में देखा होगा, that those large handsets you had, I'm not talking about the typical telephone, I'm talking about mobile phone, बड़ा सा handset होगा, एक एंटीना आप निकालोगे फिर सुनोगे. So that was a very good example of analog signal. इवन टुडे जो हम रेडियो या टेलीविजन जो हम देखते हैं विथ द हेल्प ऑफ डिश एंटीना, दैट आपके पास टाटा स्काई है या डिश टीवी है जो भी है, so the signal which you are watching, or if you are listening to a radio FM, that's a very good example of analog signal. But most of the modern communication systems, they use digital signal. So give this heading. Digital signal. A digital signal takes discrete stepwise values, digital signal takes discrete stepwise values, often 0 and 1, often 0 and 1. This is called binary system. Where 0 corresponds to a low level, and 1 corresponds to a high level of voltage or current. How many of you have background in computer science? Few of you. So I have a very simple question here is that why do we use binary system in computers? This is an open question, but I definitely expect a good answer from those who have background in computer science. That why do we use binary system? जैसे ये तो सबने पढ़ा होगा, that computers understand the language of 0 and 1. I have a very simple question here. Why is it so? Why not decimal system? The same way we are using 0 to 9. 0 to 9 are 10 digits, hence the word deci. Deci का मतलब 10 होता है. So why not decimal system? What we use in our day-to-day life. Why binary system is used in case of computers? But ये तो tautological answer हो गया ना? Why are they not capable to understand? Like we have designed them. So why have we designed them to, in a way, that they are capable of understanding only 0 and 1? Why did we not design a computer which was capable to understand decimal system, or which would have processed data in decimal system rather than binary system? It is. So again, I want, why is it more easy? Okay, perfect. That's a correct answer. I will just rephrase it a little bit, but you are absolutely correct. So the first thing we should be very clear here is that decimal system is not a unique system per se. Decimal system is only unique because that is how we learn to count, and we learn to count because of 10 fingers. We had 10 fingers. It was very easier to make 10 as a base, and then we started counting everything with 10 as a base. Now 10 as a base का क्या मतलब है? Think of how we write number 0 to 9. ये unique numbers है 0 to 9. So next number है वो 10 है. Then 11 है. Then again we go to 99, and again we become 100. So we keep increasing the power of 10. That is what we do. When I'm writing, let's say 125, then what am I doing? That 5 represents 10 to the power 0 into 5. that 2 represents 10 to the power 1 into 2, and that 1 represents 10 to the power 2 into 1. That is what this number is. So as I keep increasing the number from 99 to 100 to 999 to 1000, all we are doing is we are increasing the power of 10. If I want to write after point decimal, जैसे 1 4 है, that's also fine. This is nothing but 10 to the power minus 1 into 1 plus 10 to the power minus 2 into 4. यही है ना? So जो number system हम use करते हैं day to day life में, it is using 10 as a base. That after every some number, we have to increase the power of 10. But why 10? Why not something else? Why not 12, for example? 12 is a better base. Because often when we use base, it should have more number of factors compared to the number. जैसे 10 के कितने factor हैं? 10 का factor 1 है, 2 है, 5 है, and 10 खुद में है. But think of 12 के कितने factor हैं? 1, 2, 3, 4, 6, 12. So 12 is a better base to count. We could have used 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, ये हमारे 12 यूनिक डिजिट होते हैं और उसके बाद फिर हम आगे बढ़ते. So in 12 as a base, I would have increased this into 12 rather than 10. I would have increased that into 12. So 10 is not a unique base per se. The reason we use 10 as a base simply because we have 10 fingers and we learned how to count in the term of 10. When we designed abacus, it was in 10. So all of the devices which we made to count larger and larger numbers, to do mathematical operations, चाहे plus हो, चाहे minus हो, multiplication हो, division हो, we used 10 as a base because it came intuitively to us, because that is how we learned to count with the help of 10 finger. But once we figured that out, we realized that 10 is not a unique base. We can use 2 also. In fact, the minimum number of digits which are required to do counting is 2. That I just need 0 and 1. And I can represent each and every number with the help of just 0 and 1. I do not need any other number. So for example, in that binary system, if I'm writing something like 1, 1, 0, 0, 1, then think about it. This is basically 2 to the power 0 into 1. This is 2 to the power 1 into 0. This is 2 to the power 2 into 0. This is 2 to the power 3 into 1, and this is 2 to the power 4 into 1. Add all of this. This is 16. This is 8. This is 0. This is 0. This is 1. So essentially what I have written here is 25. So the way to write 25 in binary system is 11001. तो जैसे normal decimal system में we started from 0, went till 9, then went till 10. In binary system, we will count 0, 1. What will be the next number? So 0 is 0, 1 is 1. The next number is 2. How will we write 2 here? 1, 0. Next number will be 1, 1. Next number will be 1, 0, 0. You get the idea that how this number will increase. That we do not have to, we can write everything in binary system. And if we can write everything in binary system, we can do all mathematical operations in binary system. I can plus, minus, multiply, divide in binary system, right? And जिस तरीके से हम plus करते हैं, 10 हम लेते हैं कि 10 को हमको carry forward कराना है. In binary system when we have to add, हमको 2 carry forward कराना पड़ेगा. So you get the idea that how we can do counting and we can do all mathematical calculation with help of just 0 and 1. I need these two. Only 0 is not enough. I need 0 and 1. I need 2. And that 2 is more than enough to do any type of mathematical operation. I will repeat, decimal system is not per se that unique a system. Decimal system is useful to us because we learned to count in decimal system because nature has given to us 10 fingers. And we use these fingers to count, and it made more sense to then count in 10 as a base, and we kept increasing the power of 10. So all mathematical operations can be done even in binary system. Now let's think of, so how do we, why we use binary system in computers now? पहला तो कारण नहीं है कि computers can do calculations in binary system also. They can also do calculations in decimal system. But how do computers do calculation? They essentially use transistors and they use flow of electrons. Now transistors के साथ सबसे बड़ा benefit क्या है? The transistors can be switched on and switched off with a very small electrical current. So you can think of it like this. If there is no electrical current, then that is 0. And if there is electrical current, that is 1. So I can replicate 0 and 1 on a transistor really, really well. That if there is no current, that is 0. If there is some current, that is 1. Now think of how this would have been so difficult if we had 0 to 9. No current, 0. Up till some current, 1. Up till some other current, 2. So we needed to have a 10-step voltage so that I can represent from 0 to 9. And that 10-step voltage में जहाँ पे भी कहीं पे भी मान लो थोड़ा सा भी margin of error हो, that 4 के बजाय 4.5 read कर लिया, so 2 के बजाय 3 read कर लिया, आपका जो transistor है, all of our calculations would have been wrong. So, and the best part here is that it is not even required. So we can only make a 2-step voltage, no voltage 0, some voltage 1. Designing that into an electronic circuitry is much, much more easier. We can design an integrated circuit with the help of transistors, where those transistors are like switches, and a switch on basically means some electric current, which can be represented with 1, and a switch off means no electric current, which can be represented with 0. So representing that 0 and 1 into integrated circuit is much, much more simpler compared to a 10-step voltage, which would have been led to a lot of complications, first, and second, it would have led to a lot of error, and third, it was not even required. Because as we have already established, whatever we can do in decimal, we can do that in binary. So simply because of simplicity and error, we do not want to cause a lot of error, we designed computers into binary system. So even in signal processing, it is quite helpful. That whenever I have high frequency, I can represent that with 1. Whenever I have low frequency, I can represent that with 0. So rather than having this discrete, rather than having this continuous voltage, I can have this signal which looks something like this, where there are discrete jumps, 0, 1, 0, 1, that everywhere I have low frequency, I represented that with 0. When I had high frequency, I represented that with 1. So I can sample my signal in a way that a continuous analog variation can be represented into a corresponding 0 and 1. But why would we do that? Why not analog only? Turns out digital signals have lot of benefits. Digital signals को secure करना ज़्यादा आसान है. Digital signals are much less prone to noise compared to analog. Digital signals को repeat करना, I talked about repeating, is much, much more easier. So many things, when we do this entire signal processing with help of 0 and 1, it gives you a lot of benefits compared to analog signal, which suffers from signal distortion, from noise, not very secure also. And that is why most of our signals in modern world, they do use digital signal, which includes internet, which includes our mobile phones. Almost everything which we use, except very few things. Few things are still using analog. I told you radio, FM, dish, antenna, TV, that still is using analog, but most of the things they are using now digital signal. तो आप लिख सकते हो about digital signal? Digital signals, हमने लिखा है ना, take discrete step value, ये तो लिख लिया था हमने, आप लिख सकते हो. हमने ये भी लिख लिया था, 0 corresponds to low voltage and 1 voltage. Digital signals have many benefits. Digital signals have many benefits. They are generally more resistant to noise. They are generally more resistant to noise. Digital data can be compressed and stored more efficiently. Digital data can be compressed and stored more efficiently. Somebody had asked a question in last class that how can we store voice data or video data into a pen drive. तो जो हमारा पेन ड्राइव है वहाँ पे हम ये वॉइस डेटा हमने कोई मान लो कोई सॉन्ग स्टोर करके रखा हुआ है पेन ड्राइव में. So how can that song, which essentially is some sort of voice, can be stored into a pen drive? So now you can think of that. So or even in CD, by the way. So CD will hard disk will use some sort of magnetism. CD will use some sort of optical storage. Pen drive may use some sort of transistor only. That think how this data will be stored in your pen drive. That a transistor stored into those combinations of zeros and ones, and that 0 and 1 essential. And by the way, that is another good thing about digital signal we should know here is that we can convert all sort of signal into digital signal. So it's not that only we can represent numbers with digital signal. So think of how we are representing now images with the help of digital signal. Or how we represent alphabets with digital signal. So now we have designed a system where that capital A or that small a is represented with a unique combination of zeros and ones. So every signal processing system, they know that a particular combination of 0 and 1, that is capital A, some particular combination is small a. If you have a picture in your mobile phone, a digital picture which you have clicked, आप उसको बहुत सारा zoom out करो, and बहुत सारा जब zoom out करोगे, you'll start finding that square grid there. That आपको जो पिक्चर है वो आपको एक ऐसे ग्रिड पैटर्न में दिखेंगे, और जो एक ग्रिड होगा उसका मोर और लेस आपको सिर्फ एक कलर दिखेगा. जैसे आपका पिक्चर में बहुत सारे कलर्स हैं, बहुत ही हाई रेजोल्यूशन पिक्चर है, बट जूम आउट दिस पिक्चर अ लॉट एंड यू विल फाइंड दिस स्क्वायर ग्रिड पैटर्न, and there will be one pixel, and that one pixel will have only one color. So that, by the way, is called pixel, first of all. This is called pixel, and this one pixel is a unique combination of zeros and one. So now when we have picture with very high resolution, then many of those pixels are combined together, and जितने ज़्यादा pixels होंगे, जितना ज़्यादा color हमने superimpose करके रखा है, उतना better आपका picture होगा. So that is why high resolution pictures will occupy much more space compared to low resolution pictures. But that pixel, one specific pixel, is a unique combination of 0 and 1. And now think of videos. Videos are nothing but series of images kept upon each other. And as those images pass through us very, very rapidly, then we think of this as a moving picture. So video is nothing but many pictures stacked together. So even that video is nothing but combination of 0 and 1 only. And that is why videos occupy much, much more space compared to a picture. So we can represent everything, text ho, image ho, sound ho, pixels ho, with some combination of 0 and 1. And all across the world, we follow more or less the same system, that how a particular combination of 0 and 1, it means a particular character or a pixel or something else. आप लिख सकते हो इसको? Digital data can be compressed and stored more efficiently. Digital data can be compressed, ये लिख लिया था हमने. Write on the next point. There are several coding schemes useful for digital communication. There are several coding schemes useful for digital communication. To represent numbers, letters, characters. To represent numbers, letters, characters. Numbers, letters, characters. The most famous scheme is American Standard Code for Information Interchange. American Standard Code for Information Interchange. ASCII system. American Standard Code for Information Interchange. Let's take a break here. After that, we will discuss modulation. I'll explain why optical fiber cables are important. And then I will talk about some of the technologies which I'm going to discuss. The answers few of you had written, you can collect it here. Online students, I'm in the process of checking you. Like I was really surprised, many of you had sent the answer. So it will take some time, but I will check all of the online copies also. आपने question submit करा था, you can collect it from here. Give this heading modulation. Write down a few things in modulation. I'll explain this later. The original low frequency message, the original low frequency message, the original low frequency message cannot be transmitted to long distances, cannot be transmitted to long distances. Therefore, at the transmitter, information contained in low frequency message signal, information contained in low frequency message signal, information contained in low frequency message signal, it's superimposed on a high frequency wave. It's superimposed on a high frequency wave which acts as a carrier of the information, which acts as a carrier of the information. It's superimposed on a high frequency wave which acts as a carrier of the information. This process is known as modulation. This process is known as modulation. There are many types of modulation. There are many types of modulation, such as amplitude modulation, frequency modulation, or phase modulation. Let me explain this. Imagine I have to write something on piece of paper. I have to throw it, right? Imagine love story in school days, right? So I have to write piece of paper, I have to throw it. Maybe this will not travel very large distance, but you can wrap that piece of paper around a stone, and now you can throw this. Now because of this stone, this piece of paper is going to travel to more distance. And for the person this message belonged to can unwrap this paper and can recover the original message. So modulation is similar to like this, that you have a message contained as part of a low frequency information signal. Low frequency often means low energy. So it is not the only benefit. There are actually many other benefits of modulation, but that will often be superimposed on a high frequency wave. Just in this particular case, this is my input and this is my carrier. Carrier wave jo hai, that has high frequency. And they will be superimposed they can be superimposed in multiple ways. Just one of the ways that the resultant will look something like this. This is the modulated result after superimposition. In this modulated result, the amplitude is not the same. The amplitude varies. But this variation in amplitude is not random. This variation in amplitude follows a proper protocol so that there is a receiver few meters, few kilometers away, and that receiver can recover the original message following how this amplitude is actually changing, and it can recover the original message. Remember, in the last class I told you that communication system function if all of the devices which are part of communication system, they're following the same protocol, and some variable has to change here. So in this particular case, amplitude is changing, and because of that change in amplitude, my device, which is receiver, it can actually recover the original message out of it. That process will be called demodulation, recovering the message from the modulated result. AM radio जो हम सुनते, अब तो नहीं use करते हम AM radio. In TV we still use AM signal, particularly for video. Some channels still use that. So that will be an example of AM. But another very famous modulation technique which we use is FM. So FM radio still remains quite popular. So the frequency modulation hai, again input wave, but we use a carrier wave of high frequency. But now the modulated result, the amplitude is same, but the frequency changes. You have high frequency or low frequency, and that change in frequency, I will repeat, that change in frequency is not random. That change in frequency follows a certain rule, a protocol, and that protocol is known to the receiver, and receiver can recover the original message from the modulated result, and this process will be called demodulation. My input message does not have to be analog, it can be digital signal also, which is represented there, but even that digital signal can be modulated with some carrier wave, and this leads to various other type of techniques. So modulation is essential to modern communication, that we are changing frequency or amplitude. There is another property called phase. We do not have to go into that. Phase is a mathematical term. I have a wave. I'm assuming that these two waves, they have the same amplitude, but they clearly, this wave has much more frequency. It is vibrating more number of times compared to the first wave. So frequency represents number of vibration, but I can also have a wave of high amplitude versus wave of low amplitude. Now phase kya hai? So phase is a mathematical term, but without going into mathematics, intuitively we can understand what does this word phase mean. Think of a wave and think of another wave. I'm going to draw it together, in fact. I'm assuming that these two waves have same amplitude and same frequency, but still they are not same. Why they are not same? Because their maximas are not occurring at the same time. Their maximas are differing by some parameter here. That parameter, when we write wave equation, that parameter leads to a trigonometric function basically. Or think of another wave which may look something like this. That this yellow and white wave which you see, I can see that even if their amplitude and frequency are same, they are out of phase. Out of phase ka matlab bas ye hai that their maximas are not occurring at the same locus in space-time. And similarly, for red, in fact, that white and red, I will say that they are completely out of phase, which basically means that one of the maxima is occurring with another of the minima. So I can change the phase also. The modulated result ka jo phase hai, it can change in a way that it is not random, and a receiver knows that what that change means, and based on that it can recover the original message out of it. So people have experimented with modulation in really interesting manner. Let me now jump to some of the technologies. People have utilized modulation in really interesting manner. One of the most interesting story I have read from is World War II. During World War II, you have Allied, you have Axis power. Allied included America, Britain, France. Axis included Germany, Italy, Japan. So particularly in Atlantic and Pacific Ocean, in Atlantic Ocean particularly, you had conflict or you had naval warfare going on between Britain and Germany. France was defeated very soon. but Britain was holding its ground. And Britain and Germany, they were fighting a lot into ocean. So Britain developed a method to establish a communication with help of what we call pulse modulation. It used a very ingenious method to send information in real time. To explain pulse modulation, first let me tell you about another way to communicate, which is called Morse code. Morse code was developed by not a scientist, in fact, a person who was very much interested in postal system. And he developed a method to communicate non-verbally, or to communicate in a way which does not follow the traditional rules and regulations we follow. And for Morse code, we only use two symbols. We use a dot and we use a dash. And just with some combination of dot and dash, we can represent all the alphabets and we can represent all the numbers. So I do not know Morse code, but let's say that I have 2 dot and a dash. This represents, let's say, A, and I have some 1 dot or 2 dash that represents B. Again, I'm making it up. I do not know Morse code. I should be very clear here. Or I have some 2 dot 2 dash that is, let's say, C, something like that. That I have this various combination of dots and dash, and that represents a specific alphabet, and that represents a specific number. So I just need to remember what, like 26 alphabets and 10 numbers. So I just need to remember 36 symbols. And if I can memorize those 36 symbols, so now I can write a letter in Morse code. I do not have to write, how are you? I simply can write this combination of dot and dash. And if the person for which this letter meant for understand Morse code, will be able to recover it. Remember, some variable has to change. So in this case, that combination of dot and dashes that is changing for each and every alphabet and for each and every number. So just with the help of dot and dash, I can communicate. But Morse code often is used even in live communication. Just say, let's say we developed some sort of tool. We do not have to speak a single word. We use blinking of eyes or tapping of finger. Let's say that if I tap this finger once, that is a dot, and if I tap very rapidly twice, then let's say it is a dash. So if I tap it and then tap, double tap, that is a combination of dot and dash. That represents a letter, and I keep doing that. You juxtapose all of those letters together and you find a word. That this is what I'm trying to say. So even today in military academies, this is taught. So a lot of military personnel still they learn about this. There was a very interesting story when US-Vietnam war was happening. Then one of the US army personnel was captured by Vietnamese. And while he was being tortured, there was a video recording of him. It was made apparently in a like nice condition. And with blinking of eyes, he was able to convey the message torture, that he is getting tortured. And that was used by US to impose diplomatic pressure on Vietnam to free him. So this is a non-verbal way of communication, that just by blinking eye or just by tapping finger, we can establish a communication channel. However, goes without saying that everybody needs to know Morse code. If you do not know the Morse code, then you will not, that will simply seem gibberish or also crazy, that what is, or maybe not a good person, blinking of eye. So think of it like this. So Morse code can be a very powerful tool to establish a non-verbal communication also. So what Britain did in World War II is that in London they had a transmitter, a radio device which can transmit radio signal. And then on the ships they installed receivers. And all they did is that switched on and switch off the transmitter. So there is a radio device which is transmitting signal, but they switched it on. So now think of if I switched on and switched off once, that maybe is a dot. Maybe I did that very rapidly, maybe that is a dash. So there is a receiver at ship somewhere few hundred kilometers, few thousand kilometers away from London. But because it is a radio wave which travels with speed of light, so the moment I transmitted a signal, it was received by a receiver at the ship. And there is a device which is monitoring all of that dot and dash based on that switching on and switching off. And there is a person who can make sense of what that means. Maybe it will tell them about the coordinate of enemy or something like that. And they can plan their attack accordingly. And that must have played some role in giving them upper advantage. Clearly, Germany lost later, and Britain and America emerged victorious. So people have, again, in modern world, it is not going to work because everybody knows Morse code, and this will be not a very secure channel of communication. But at that point of time, nobody even knew, or nobody had thought of that this is how you can establish a communication channel. So people have this, by the way, this technique is called pulse modulation. So people have experimented with modulation for last 50, 60 years, that how we can modulate our signal and how we can send communication signal to large distances. We are using even today such techniques in various type of emerging technologies. So before I go into 5G, let me talk first about a new emerging technology which we call Li-Fi, light fidelity. Give this heading, Li-Fi. This is also called visible light communication, VLC. Visible light communication. Visible light communication. So typical हमारा Wi-Fi router है that uses radio waves, that uses this frequency of 2.4 or 5 gigahertz, which is radio wave. Radio waves have a lot of benefits, I told you. They can cross solid objects very easily. Producing radio wave is much, much more simpler. Many benefits radio waves have, and because of that in modern communication we do use radio waves. Can we use visible light for communication? Can we use light, this light, to send data, to send that 0 and 1 from one place to another place? So as it turns out that yes, we can. And this was demonstrated by in one of the TED talks, in fact. TED talk किसी ने देखा? YouTube पे बहुत सारे TED talks available हैं. So in one of the TED talks, I am forgetting the name of the scientist who actually demonstrated for the first time. He demonstrated that with help of an LED bulb, so he developed, what he did here is, he used an LED bulb whose intensity is going to flicker very, very rapidly. So its intensity is not fixed, it's flickering, it's changing. But that change is very, very rapid. And that change is so rapid and so small that our eyes will not be able to even make sense of it. That our eyes cannot make sense of what is happening to this LED bulb. So, but it is flickering. However, there is a photo detector, a sensor, which can detect with very high precision such type of changes. And that change is not random, that change is following a certain protocol, that change is a way to transmit those zeros and ones which we talked about. So an LED bulb which is flickering very, very rapidly, but that flickering is not random, and that flickering we cannot make sense of it. Our eyes are not strong enough or powerful enough that they can intercept that flickering, so it will not cause any problem to our overall visual. But there is a photo detector, a device which can monitor that flickering, but that flickering is not random. That flickering is a way to send those zeros and ones, and it can convert those zeros and ones into a suitable electrical signal which can be converted into whatever data input that is. Using that, I can send sound or image or video also. And in a live demonstration on TED Talk, he demonstrated that the speed which you can attain from this device will be 10 or 20 times faster than a typical Wi-Fi router. At that point of time, Wi-Fi speed was quite less. Abhi things have improved a lot. But even today, Li-Fi can attain much, much more faster speed than Wi-Fi. So we are not using radio waves here. We are using light as a medium of communication, visible light. We can use infrared also, but often we use visible light. And with the help of visible light, we can communicate zeros and ones to a receiver which can monitor that flickering of the light. Now I have a question here, that what type of challenges do you think will occur in such communication system? Whatever I have explained till now, based on that I have a question, that I have this LED bulb which is using flickering of light to convey a message to a receiver. But what type of challenge will be there? Lot of? Okay, obstruction because of? परफेक्ट. तो सबसे पहला प्रॉब्लम क्या होगा, दैट ये जो सोर्स ऑफ लाइट है, जो एलईडी बल्ब है, रेडियो वेव्स के लिए वॉल जो है ट्रांसपेरेंट है, बट विजिबल लाइट के लिए तो बिल्कुल ही नहीं है. So I can attain all of that communication system which will be very faster within a room. But outside room, and particularly if room is opaque, then I cannot transfer that data. That is one problem. What will be the other problem? Sorry? Privacy actually is quite good in Li-Fi. In Li-Fi, your data can be much, much more secure compared to typical Wi-Fi. Privacy is not a challenge. Sorry? Let's assume that I have a very good LED device. It's not going to mix function. What will be the noise here? Perfect. Think about it. What will be when I use the word noise? I talked about signal, that I have a signal, but there are unwanted signals, undesirable signals. I call the noise. So for this Li-Fi device, what will be source of noise? Other light sources. So I have an LED bulb which is flickering, and a photo detector which can monitor that flickering. But what if that photo detector is also receiving light? For example, let's say you have windows which are transparent and open, and lot of bright sunlight is entering, right? Or you have other sources of light in the room itself. So it cannot work really well outside the room where sunlight is very bright. First problem. And even within room, the other light sources can affect the capability of that photo detector. So you have source of noise also, and you have to minimize that noise. So that is why till now जो Li-Fi के जो use cases हैं वो बहुत limited हैं. We are using that, or in fact very limited applications we are using. But that is why I made a statement that this is an emerging technology, that people are exploring use of visible light to send data from one location to another location. Those zeros and ones which we talked about, people are trying to think how can we do that. आप लिख सकते हो about Li-Fi? Light fidelity. The full form of Li-Fi is light fidelity. The same way Wi-Fi का जो full form है, that is wireless fidelity. Write down, it is a wireless communication technology. It is a wireless communication technology. Wireless communication technology that utilizes visible light, often from LED light bulbs, to transmit data, It uses high speed flickering of LED light bulbs. It uses high speed flickering of LED light to transmit data. This flickering is so fast This flickering is so fast ब्रैकेट में लिख लेना millions or billion times per second. This flickering is so fast that it's imperceptible to human eyes. Imperceptible to human eyes. A receiver ब्रैकेट में लिख लेना फोटो डिटेक्टर, फोटो का मतलब लाइट है, a receiver photo detector can sense this rapid flickering, can sense this rapid flickering and convert it back to electrical signal, which are then converted back to binary data, I will need sound in YouTube video. एक बार बोलना ITT में I will need sound in YouTube video. Write down. Li-Fi can achieve much faster speed than Wi-Fi. It does not use radio frequency spectrum. It does not use radio frequency spectrum. So it does not interfere with other radio frequency devices. Such as Wi-Fi router, radios or cell phones. However, light does not pass through walls. This limits the range of Li-Fi. This limits the range of Li-Fi. Also, bright sunlight or other strong light sources can interfere with operation of Li-Fi. This is one of the emerging technologies. Lot of limitations though. You cannot have very large range, and because of that it has not found lot of applicability. But in a room, if you want to transmit data with much faster speed, with very high security, Li-Fi can be quite useful here. But apart from that, it's not that useful. So that is something we should know. Let me come back to the point that why optical fiber cables are so good at providing very high bandwidth. You have studied reflection and refraction of light in your school textbooks. Let's say I have a mirror, some light falling here. I draw a perpendicular from this mirror. This is angle of incidence. At same angle, this light will be reflected. We have studied that as law of reflection. This is reflection of light. We also have studied refraction, that let's say this is water. Light enters here. and this light bends towards the normal if it is entering from rarer to denser medium, right? This is called refraction of light. Because of that refraction of light, this pen is going to be look, ye straight line nahi dikhega. You can have a lot of optical illusions because of refraction of light. The same thing happens if light is entering from denser to rarer medium. Let's say that this is my denser medium and this is rarer medium. Same thing happens. This light moves away from the perpendicular. If I increase this angle of incidence, there is a chance that it moves exactly at 90 degree, and beyond this angle, it is not at all going to the next medium. It will completely reflect in the same medium. So this phenomena is called total internal reflection. Total internal reflection happens when you have light traveling from denser to rarer medium, and beyond certain angle of incidence, there will be a situation that this light will not go to the second medium. मान लो ये मेरा first medium है, ये second medium है. I can assume first to be glass, second to be air, and there will be certain angle that beyond this particular angle, this light will not at all enter to the air. All of that light will simply be reflected back into the glass itself. This phenomena, which by the way is happening because of refraction, but it is called total internal reflection. Why total internal reflection? Because the previous phenomena which I talked about, this mirror here, mirror can never have 100% reflection. Some light will always be absorbed. आप कोई भी घर पे आप experiment करके देख लेना, take a mirror, take a flashlight, incident that flashlight and look at the reflection on the wall, and you will find that the brightness of that reflected light has decreased a lot. It's a very simple experiment. So mirror cannot do 100% reflection. Some light will be absorbed there. This is a phenomena where there will be 100% reflection. All of that light will be reflected in the same medium. Hence the word total internal reflection. This optical phenomena can explain so many different things. It can explain why diamond shines so much. जो diamond का crystal structure है, it allows total internal reflection to occur, and because of that, whatever bright, जितना bright sunlight होगा, diamond is going to shine more and more, and it can, because of the fact that light travels with different distance, it can produce all of those beautiful colors when you look at from different angle. This also explains a phenomena called mirage. आपने पढ़ा है? There is something called mirage. What happens in mirage is that you go on a open road in summer season. कोई बिल्डिंग नहीं है, कुछ नहीं, आसपास दूर दूर तक पेड़, बहुत कम पेड़ है. मान लो डेजर्ट जैसे एरिया में हो आप. But does not have to be desert. Anywhere you are on an open field and it is really hot outside. You are feeling thirsty, you do not have water. Suddenly you see that there is a water source few meters away from where you are standing. And then you go to that source and you do not find any water there. You do find a tree, but you do not find any water. So what happens there? Like, why did you think that there was a water source when there was no water source here? And that can also be explained with the help of total internal reflection. That in summer season, when temperature is really, really high, the land warms up much, much more faster. And because of that, the air which is closer to the land, that warms up faster. And faster in open air, high temperature air is going to disperse. This will cause less pressure. This air will become rarer compared to air which is few inches above the land. And that still is not hot enough compared to the land itself. And that air is at low temperature. And because of that, that air is densely packed. So you have air touching the ground, which is not that densely packed, but air above the ground, which is densely packed. So within air, now you have variation in refractive index. That within atmosphere itself, you have rarer medium, you have denser medium. And by the way, I'm not even talking about troposphere and stratosphere. I'm talking about few hundred meter, not few hundred, sorry, few meter above the ground. Now what this will lead to, that some light coming from that palm tree, for example, in this particular case, that light undergoes total internal reflection because of this phenomena, And we do know the impact of reflection. Reflection leads to an inverted image. Now, our brain has evolved to think that if I see an inverted image of a tree somewhere, then it must be because of some pond, some lake there. So immediately your brain is going to tell you that this inverted image is because there is a water source there. This is how we have evolved. Like water, looking for water sources was something which we actively did. Think of our life as hunter and gatherer. Now we are in civilizations, but we did live for thousands of years as hunter and gatherer. Finding food, finding water was a challenge. So, and by the way, many human beings, they emerged out of Africa, and not a lot of water resources. So finding water was a very important thing to do. So finding water, so your brain is tricking you, and you have this internal mechanism arranged in a way that the moment you see an inverted image of a tree, it means that there is a pond, there is a lake. Your brain is telling you that there is a water source, and when you go there, there is no water source. So now we know that why does it happen? It happens because of this phenomena called total internal reflection. If you can take an optical fiber cable, optical fiber cables are often quite thin, less than millimeter thin. But if you can zoom them, if you can look them with the help of a microscope, you will find that within that thin layer, there are two further layers here. You have a material at the center of this cable, which is called core, and around this core, you have another material which is called cladding. So you have basically two materials within that very thin strand, which we are calling optical fiber cable. You actually have two materials. At the center, you have some other material, and around it, you have some other material. And the center ka jo material hai, that has higher refractive index compared to this cladding material. So that center material, jo core hai, that is denser compared to the clad. In typical communication system, we convert that radio signal in light pulses, and those light pulses then undergoes total internal reflection in the core itself. So even if this light pulse has traveled hundreds of kilometers of distance, there was not a single absorption anywhere. And because of that, after hundreds of kilometers of distance, thousands of kilometers of distance, it still will maintain its same strength and same intensity. So why optical fiber cables provide you very high bandwidth? Simply because your signal does not attenuate. And why that attenuation does not happen? Because all the time your signal is undergoing total internal reflection. In total internal reflection, there is no absorption. All of the light is simply going total reflection. So you can now have a signal traveling for hundreds of kilometers without any type of attenuation, and hence so much of bandwidth is provided by optical fiber cable. Right? So this is something we should know about optical fiber cable. आप लिख सकते हो? Optical fiber cable. Optical fiber cable is made of two materials, a core of higher refractive index, a core of higher refractive index, compared to a cladding around it, Signal inside optical fiber cables, travel as pulses of light, and undergoes total internal reflection. Because of this, It can travel to hundreds of kilometers. It can travel to hundreds of kilometers without attenuation, without attenuation, without attenuation, which simply means without losing its strength, without attenuation. That is the benefit of optical fiber cable, that without attenuation your signal can travel to much farther distances. I can use all of that together in explaining how does a mobile phone work. There is a very beautiful YouTube channel. They have these really good animations. This channel is called Lesics. You can use this LESICS. And you can use this channel to understand many types of technology. I will show you just one video here, and I will not show you the entire video. Rest of the video आप घर पे देख लेना. How does a mobile phone work? How does the mobile infrastructure work? Let's try to understand that. If, let's say, somehow you could have ensured that the electromagnetic wave in the air does not lose its strength at all, even then we need to have systems in place so that signal can be recovered and sent in a directed form, because waves will travel in straight line and Earth is not a flat surface. Earth has curvature because of spherical surface. So if you want to emanate a wave from here, it is going to go into space then. Right, so it will travel to some distance, but after a few hundred kilometers, you cannot neglect that Earth's curvature part. If you want to send a signal few hundred kilometers away, then, and if you are not accounting for Earth's curvature, then your communication system is not going to function. That is the meaning of this particular reason behind it, that it can be mathematically shown that hexagonal is the best optimized shape so that you can cover maximum area with minimum number of mobile towers without overlap and without intersection. So I can cover this with circle also, but the problem is that if three circles are only touching each other, then there will be a space which will be left. We do not want that to happen. Then I can do that with help of, let's say, equilateral triangle or square, but it can be shown that hexagon will be the best shape here, which can lead to maximum coverage of area with minimum number of mobile tower. So hence hexagonal shape. That is important, that you think that entire mobile communication is wireless, but that is not entirely true. Mobile towers themselves are connected with cables, and hopefully if they are connected with optical fiber cables, it means they can handle more and more amount of data. So watch this rest of the video. The name of the channel is Lesics. The name of this video is How Mobile Phone Works. And you can find another, in this entire series, you have this very next video, How Does Internet Work? And you will realize, you'll be able to appreciate even functioning of internet. So internet requires these optical fiber cables. That you'll find cables, very thick cables deep inside oceans, connecting all of the world. And if I can show you this very complex infrastructure, I might have a slide on that. Yeah. So the entire world is connected with the help of the subsea optical fiber cables. And because of that, internet is possible. That everywhere there's, I want to watch a video on YouTube. That video is stored somewhere in California in a data center owned by Google in some solid SSD device, very similar to hard drive, but much more sophisticated. And then I want to watch this video, or I want this data transmission to occur on my device, on my mobile phone, on my laptop. So all of that functions because of the help of these optical fiber cables, and because of the fact that every device on the system will follow the same rule and protocol. Just the simplest protocol will be that every device will have a unique address. We call that IP address. ये तो सबने पढ़ा होगा. That every device, despite billions of devices, every device has a unique address, and this unique address can be traced where a particular device is located. So that is how even global internet connectivity works, and such huge amount of data all the time is transferring from one place of the world to the other place of the world. So that subsea cable network is essential for modern internet to work. So let's talk about few more technologies here. Give the next heading, free space optical communication. Free space free space optical communication. So this is another method to use visible light for communication. I still haven't started talking about 5G. I still am into how we can use visible light. But free space optical communication is different compared to Li-Fi. And this is another emerging technology, but this is becoming much, much more popular. Li-Fi is not very popular as of now, but free space optical communication is actually quite useful. In free space optical communication, we use many radar devices and satellites. And then we use visible light, often laser light. Laser light के कुछ benefits हैं. When we use the word laser light, laser is different from this source of light. How are they different? Anyone who will tell me how is a laser light source different from a typical light source? Yes, go ahead. That does not have to be necessarily true. It is monochromatic. That is one of the feature of laser light is it is often monochromatic. Monochromatic का मतलब होता है that light has only one frequency or only one wavelength. So जैसे think of a typical white light source. White light का जो wavelength है 380 to 700 nanometer है. But think of even red light. Forget about white तो चलो 7 color है. Think of even the word red light. Red light के कितने अलग-अलग shades हैं? And all of those shades they essentially signify a particular frequency or a particular wavelength. So even red light has all of these different wavelengths. So let's say even if I have a red light source, then उसका भी अपना एक spectral width होगा, which basically means that उसका भी एक minimum and maximum frequency होगा. जैसे red light कहाँ पे होगा? 380 पे या 700 पे? 700 पे should be very clear. जो पूरा violet जो है उसका energy ज़्यादा है, frequency ज़्यादा है, and hence wavelength उसका कम होगा. So wavelength of violet will be less. So even a red light source can be, let's say, from 650 to 700 nanometer. That is its spectral width. It's not monochromatic. It is multiple frequencies together. But when I'm using the word laser light, then there is a very good chance that if I'm using a red laser light of 650 nanometer, so minimum will be 650 nanometer and maximum will be 650 plus 10 to the power, let's say, minus 3 nanometer or minus 4 nanometer. So compared to 650, 10 to the power minus 4 is almost 0. So I can easily say that this is a monochromatic light. When I'm using the word monochromatic light, it means it is only one frequency or only one wavelength. So that is one of the benefit of laser light, that it is highly monochromatic. It does not contain range of frequencies, but it has only one frequency. Or the range is very thin, almost negligible. What are other properties of laser light? It is highly directional. Okay, what does that mean? All light is directional. Light to sara directional hai. But when I'm using the word laser is highly directional, what does that mean? It is linear. So a typical light source, think of your flashlight. आपके घर में torch है. A flashlight, as light extends, it extends into area. It increases into area. तो जो laser का जो increase होगा वो almost negligible है. Laser can travel to hundreds and thousands of kilometers and it is not going to spread. So, and because this light is spreading, its intensity will reduce, but laser, since it does not spread a lot, whatever intensity I produced, I can have the same intensity, even few hundred, and very high frequency, very high intense laser even for few thousand kilometers. So the third benefit of laser light here is that it is very intense. It is monochromatic, directional, intense. There are many other properties, but for me, these three properties are more than enough to explain the concept of free space optical communication. Free space optical communication, we use visible light, we use laser light. Laser light, जिसका frequency ज़रूरी नहीं हो बहुत ज़्यादा हो, but laser light which is highly intense, which is unidirect or which is highly directional, and that laser light we are changing some of its parameter, we are changing its frequency or amplitude, that modulation which we talked about, and that change is not random, that change is sending some combinations of zeros and ones to a receiver. The benefit of this here will be that laser light can travel even in very bright sunlight. That if I have a laser beam, you can easily buy laser light source on Amazon. It's not that costly also. And आप laser light use करो sunlight में, and you can see that laser light falling on a particular place, even after few hundred meters. So laser light का benefit ये है that despite the outside light, I still can resolve, or I can still find that direction in which laser light is traveling through. So free space optical communication is different from Li-Fi. The common feature here is that this also uses visible light to send data. But the difference here is that it does not use that flickering of LED bulb. It uses laser light. It modulates some of the properties of laser light. That modulation is not random. It sends zeros and ones, which can be received by a receiver. But now this receiver does not have to be just few meters away. This receiver can be few kilometers away also, and it's fine. But एक challenge अभी भी होगा, that it cannot cross solid objects. वो challenge अभी भी होगा. जैसे if I have a sender, I have a receiver. They have to be perfectly aligned. Small misalignment, I cannot have communication. Between a sender and receiver, another solid object, I cannot have communication. So that challenge still is there. That solid objects can obstruct this signal transmission, and that is why often we will try to use that outside. But जो दूसरा problem था, जो noise का problem था, that जो bright sunlight है या strong light source है, that will act as a noise, that is not a problem in free space optical communication. So this is another technology where we are trying to use visible light, but this visible light will be very useful for communication outside our room. आप लिख सकते हो? Sorry? तो हम जनरली हम एटमॉस्फेयर में करेंगे, हम मीडियम में हम नहीं करेंगे हम इसको. सॉरी, मिराज वाला कॉन्सेप्ट यहाँ पे क्यों होगा? वी कैन नेग्लेक्ट. सो ये इस टाइप के जो कम्युनिकेशन सिस्टम है, जो लेजर होगा, दैट विल नॉट सफर फ्रॉम सच टाइप ऑफ प्रॉब्लम. एंड बाय द वे, व्हेन वी थिंक ऑफ मिराज, we think of some light undergoing total internal reflection because of some object, and that leading to some inverted image, and that is causing all of that optical illusion. Yahan pe we are talking about a light which is simply propagating, right? So the question is that, will this light undergo refraction if it is, let's say for example, traveling in a place which has all those stratified layers of air, right? That change, whatever impact that will be, it will be negligible. So technically the answer is yes, but we can, if let's say we are trying to utilize this system in such type of places, then we just have to ensure that our transmitters and receivers are perfectly aligned to each other, accounting for that refraction, accounting for that total internal reflection. आप लिख सकते हो? In free space optical communication, it refers to transmission of modulated visible or infrared beams, modulated visible or infrared beams through the atmosphere to obtain optical communications, Unlike traditional optical communication, which uses fiber optics, unlike traditional optical communication, which uses fiber optics, FSOC, free space optical communication, FSOC uses free space as the medium. FSOC uses free space as the medium. Write down that data signal is used to modulate a light source, often a laser. The data signal is used to modulate a light source, often a laser. Often a laser. And a photodetector can receive the incoming light signal, converting it into electrical signal. ये हम डे टू डे लाइफ में यूज करते हैं, बाय द वे. Converting light into electrical signal. Think of all the remotes, how they function. That remote is essentially producing infrared light, which is being received by the circuitry of your TV or AC or whatever device you are using. And that sends an electrical signal which can allow a particular device to switch on or switch off, right? Write down few more points here. FSO provides high bandwidth. FSOC provides high bandwidth. High bandwidth, does not interfere with other systems, other systems. However, atmospheric factors such as rain, fog, snow, dust, atmospheric factors such as rain, fog, snow, dust can scatter the light and weaken the signal. Communication link can be broken. If something obstructs line of sight between transmitter and receiver. If something obstructs line of sight between transmitter and receiver. बट ये काफ़ी पॉपुलर हो रहा है बाय द वे, जो फ्री स्पेस ऑप्टिकल कम्युनिकेशन है. दिस इज बिकमिंग मच मोर पॉपुलर टू सेंड सिग्नल, एंड द बेस्ट पार्ट हियर इज दैट दिस operates independent of all of this license mechanism. I will explain what this license mechanism in the next class. You can solve two questions here, two objective questions asked by UPSC. This question, for example. There's a question, how undersea cables are laid with the help of ships and submarines and specialized vehicles. There are submersible vehicles, small vehicles. So often with the help of small submersible vehicles, submarines and ships, these cables are led inside sea. क्या होगा आंसर यहाँ पे? ये तो बहुत easy है. Uses light as a medium for communication, several times faster than Wi-Fi. Solve this question. क्या होगा आंसर? VLC uses electromagnetic spectrum wavelength 375 to 780. That makes sense. We are talking about visible or infrared light. It is known as long range optical wireless communication. We can never call it long range optical wireless communication. VLC is Li-Fi basically. तो ये तो हम बोल ही नहीं सकते. Second statement is not correct. वहाँ से भी आंसर आ गया because if you look at the arrangement of options, out of 4, 1 is incorrect. I know that only 1 is incorrect. I need to choose that incorrect option. Third is of course correct, that it can transmit large amounts of data faster than Bluetooth. अगर ये Wi-Fi होता तब भी सही होता, Bluetooth का speed तो बहुत कम होता है. The fourth option is debatable. Fourth statement is not a complete statement. That statement is saying that VLC has no electromagnetic interference. It essentially is talking about presence of other devices. It is talking about it has no electromagnetic interference because जो typical devices जो हम use करते हैं, mobile phone हो, Wi-Fi हो, all of these devices they are using radio signal. And Li-Fi uses light wave. Frequency इतना ज़्यादा अलग है that कोई interference यहाँ पे नहीं होगा. But will VLC be affected by other light sources? The answer is yes, it will be affected. Are those other light sources example of electromagnetic wave? The answer is yes, they are example of electromagnetic wave. So fourth statement is not a very well framed statement, but UPSC does that. In any case, in this question, second तो कहीं से भी सही नहीं है. Like second is the first statement which I will eliminate. Fourth, in a particular context, it is true that it has no electromagnetic interference because of typical radio devices which we do use in our day-to-day life. So fourth is correct. 1, 3, 4 is the correct answer. Answer will be C here. So I keep repeating, questions asked by UPSC will not be very difficult. I will take 2, 3 more minutes of your time. I briefly wanted to talk about the handout which I have. I think it should have been uploaded on your portal. There are, like, if I try to make an exhaustive list, I can make tens of missions, but that's not required. Remember, before prelims examination, पिछले साल भर में जो missions हैं, जो news में थे, even if they are missions of NASA or ESA, and we should only know their objective, and we should know whose mission is this, कौन से agency का mission है. उसके अलावा, nobody is expecting you to know anything else. But I have only mentioned here few of the missions which we should know irrespective of the fact that if they are in news or not, because of the ambition they have. One of the first is James Webb Space Telescope, launched about 3 years ago. Into December 25, 2021 it was launched. I talked about this telescope in classes, that it is such a powerful telescope because of many factors distinguishes this telescope compared to previous telescopes which many space agencies have launched. And we can compare this with another telescope of NASA itself, that is called Hubble telescope. It has all of these mirrors, 18 mirrors, occupying a much larger area. Much larger area basically means that it can gather more and more amount of light. So that सबसे पहला जो distinguishing factor है वो तो size ही है. That it is a very large telescope with very large mirror which can gather more and more amount of light, and it can shed and it can provide us more information about distant cosmic sources. Second, that it does not observe universe in visible light. It observes universe in infrared light. जो Hubble telescope है, that observed universe in ultraviolet, low frequency ultraviolet and visible light. Infrared light का एक benefit है. जैसे एक simple सा example ले लो, that अचानक से बहुत आंधी आ जाए, dust हो. Literally this is true. It's not a allegory. It's not like कि ऐसे होता होगा. ये अर्थ पे भी हम witness कर सकते हैं. That let's say you have a dust storm. Dust, it's so strong that you are not able to see what is few meters away from you, because all the time dust is obstructing your line of sight. If you can have infrared sensor, then you can literally see beyond this dust. Infrared light will not be affected by dust particles. All of us, we are emitting infrared. all of us have some body temperature, and because of that all of us emit infrared. Jaise in this room, if I switch off light of this entire room, it becomes very dark, and I still can see all of you if I have an infrared sensor, because all of us emit infrared light all the time. So infrared light के benefits ये हैं that it can monitor things through dust, and in universe there is lot of dust. We have a lot of stellar dust, cosmic dust, and looking beyond that cosmic dust can become very problematic if you are trying to do that in visible light. But if you are trying to gather infrared light, then infrared light can easily cross through that dust, and now you can see even distant objects. So the second reason, or the second way how this telescope is different from previous telescope, that it observes objects into infrared light, noise, right? The third thing is that where is it located? It is not, so jo Hubble telescope hai, that is located in about 570 kilometer, which is a low Earth orbit. It is an Earth-bound orbit. But jo Webb telescope hai, that is located at L2 point, which I was talking in the space technology class, 1.5 million kilometer away from Earth. That is the third way how it is different from other telescope. And the quiz I gave you, right, usme ek option tha that it operates at very close to absolute zero, and that was correct. Now why that is correct? First, to explain that, let me show you what that sun shield means. That if you look at this telescope, this is the complete structure. Now this is the mirror part. But what about this part? By the way, this part is really large. This part is as large as this room. This room should be as large as tennis field. So ये जो structure आप देख रहे हो यहाँ पे, this structure here is a sun shield. So this structure, so in a way how this telescope operates here is that you have this sun shield and mirrors, and sun is in this part of the sky, and mirror is exactly opposite to the sun. This part has solar panels. Those solar panels are important. यहाँ पे solar panel लगा हुआ है. That solar panel is important to provide power source, send data back to Earth. But it has many layers here. What do? They keep filtering sunlight. They do not allow sunlight to reach to the mirror. Why they do not want to do that? In fact, this sun shield is so powerful that the part which is facing the sun, the temperature will be in the range of some 85-90 degrees Celsius, very high temperature. And the part which is connected to the mirror, their temperature is at in the range of -233, in fact even -250 degrees Celsius, where nitrogen or hydrogen or oxygen, all of them can exist into liquid state. So this sun shield is so powerful that it does not allow any sunlight to come to the mirror. Why do we want that? Because when objects heat up, they start emitting infrared. So if mirror starts receiving sunlight, then it will start emitting its own infrared. We do not want its own infrared to obstruct the infrared it is gathering from the distant sources in the universe. That we want this mirror to emit almost no infrared light, so that when it is gathering infrared of distant sources, we can be very confident that it was not mirror's own infrared. Mirror did not in any way obstructed our observation. All of that infrared is essentially because of some distant source in the sky. So that is why this very low temperature operation of James Webb Space Telescope. That we do not want this mirror to warm up, because that can obstruct its own observation. And because of all of that, when you look at the objectives of this mission, it aims to know the very first light of the universe, the very first stars and very first galaxies which were formed. It can also know about formation of planetary system or even origins of life. I already have told you that as of now, a very interesting work is happening, that some group of scientists, they are analyzing data from a exoplanet few hundred light years from Earth, and this planet may have traces of light. So this telescope has found a particular gas called dimethyl sulfide. And जो dimethyl sulfide जो धरती पे मिलता है, अर्थ पे मिलता है, that is because of phytoplanktons in ocean. So this telescope already has found CO2, it has found CH4. So carbon dioxide and methane already has been confirmed. Water has been confirmed. Now dimethyl sulfide, if that is confirmed, then if we try to correlate with Earth data, Because on Earth, dimethyl sulfide is emitted by phytoplanktons, basically microscopic organism which work like plant but found in oceans. And those phytoplanktons, they often release that dimethyl sulfide. So that may be a sign of life on this particular planet. So that is the meaning of this particular last point, that it can even find traces of life on other planet. So this is about James Webb Space Telescope. इस पे यूपीएससी ने एक डिटेल में क्वेश्चन भी पूछा था पास्ट में जेम्स वेब स्पेस टेलीस्कोप पे. The second program, which again is because of ambition we should know about, is Artemis program. So NASA became the first agency to send a manned space mission to moon. All of us know about it, that Apollo mission, completed in 1969. And NASA in 2019, when 50 years occurred of this mission, they announced that they are going to plan another mission, but this mission will be now launched into phases. And Artemis 1, this already has been completed. This was completed last year, 2 years ago. Artemis jo hai, that name comes from Greek goddess Artemis, twin sister of Apollo. So Apollo is a Greek god, Artemis is twin sister of Apollo, and hence the name is connected to the Apollo mission. Artemis 1 mission, it essentially contained this particular spacecraft which was called Orion. The purpose of Artemis 1 was that this Orion will go to the moon, will revolve around moon and come back. And it came back, it landed on Earth, it was recovered, everything happened safely. Artemis 2 mission, which will occur either this year or next year, that will now include a crewed mission. Few astronauts inside that Orion spacecraft. Again, they will go to the moon, they will revolve around moon, not land, they will come back. Artemis 3 will be a crewed mission, where again group of astronauts will go to the moon, but now they will land, and they will land in South Pole. The same South Pole which we talked about in Chandrayaan 3 mission, and they are going to explore South Pole for certain resources. And then Artemis 4 mission, which might occur by end of this decade or by next decade also, that is a long-term plan of NASA, that we are going to create a space station around moon. So abhi jo international space station hai, they now want to make a space station around moon, and they want to create a colony on moon. That from that colony on moon, we will send other planetary mission, and that will go on for the next few decades. So like it's a decadal plan. It's a plan which will involve few decades and will happen into multiple stages, 1, 2, 3, 4. So I think that this is also because of the ambition of this mission. We should know about Artemis program. Another mission, third mission, the last one, is OSIRIS-REx mission. OSIRIS-REx mission, what it achieved is nothing sort of a miracle. There is an asteroid, not between Mars and Jupiter, but an asteroid which is called near-Earth object. It revolves very close to Earth. Not that close that it will come and collide with Earth, so we are safe. That should be very clear. This asteroid is called Bennu asteroid. Bennu is a very old asteroid. It is about 4.5 billion year old asteroid. So as old as solar system itself, or perhaps older than Earth also. It's a very small object. Like Bennu का जो पूरा size है वो Eiffel Tower से थोड़ा सा ज़्यादा बड़ा है. जो Eiffel Tower France में. It's not a very huge asteroid per se, but it is rich in carbon. So NASA sent this mission called OSIRIS-REx. This is the orbit of Bennu. It orbits very close, orbits around Sun, and its orbit is very close to how Earth orbits around Sun. This mission traveled few million kilometers away. This mission was launched in 2016, reached to the asteroid Bennu 2 years later in 2018. For few months, it explored this entire asteroid. Then in 2020, it executed a maneuver where it touched the surface of Bennu and did an excavation, collected some sample, a sample containing about 300 grams of sample, kept that into one of its container, which was stored around a heat shield, came back to Earth in low Earth orbit, threw that sample on the ground, which was recovered in desert of America, Utah desert. And people, as we speak, people are actually analyzing that sample, and then started its another mission to another asteroid. Now it is going to explore this another asteroid called Apophis. So, and all of that we were able to achieve because we understand how gravity functions and how we can use gravity for our own benefit. So this will not be a sample collection mission now, jo Osiris Apex. So this has been renamed now. This mission is now being called Osiris Apex mission. But this is not a sample collection mission. This will just go and monitor the asteroid and collect data about it. So again, this I have included here because of the ambition, but not the ambition which has to be achieved. It already has been done. Everything which I have explained here, this already has been completed. So this entire journey, it took about like 1.5 billion kilometer. So this entire journey of Osiris Rex, it included few billion kilometer, and it has been successfully completed. In next class, we will start our discussion. We do not have a class tomorrow, I guess. But in next class, we will talk about 5G. I will talk about 5G, the technologies of 5G, and other aspects of communication technology.